Good morning, everyone, and a very warm welcome to the YGC 10 Explore series. So as part of YAL Geek Challenge Season 10, we this time has introduced a set of webinars where we are going to explore the problems, and through that, we are going to identify different opportunities available in different fields. So last weekend, we had a couple of webinar series, and this weekend, we are starting with identifying the opportunities in the field of electronics. So today, in order to do this session, we have an eminent speaker with us who is our speaker this morning is going to be Mr. Ruben Kanabadi Pillai, founder of Silicon Valley Startups, and he is also the Director of Sales Engineering at Western Digital. And he is also an author and mentor for budding entrepreneurs. So without taking much of your time, let me hand over the session to our speaker. Ruben, over to you.
Thank you, Aparna, for having me on this session, as well as for all of you guys who listen to this series. YAL IT Hub is doing an excellent service. I have been associated with this group for a while now, at least 3-4 years, with Aparna, Sayandan, and many others. And I think they do a great service to Sri Lanka, and importantly, northern part of the Sri Lanka, and trying to help people connect with the world with new technologies and new ideas. So in that series, they had invited me to come and discuss about electronics. So let me quickly do a share screen and. So while it is opening the slides, I would like to introduce myself first. My name is Ruben Kanabadi Pillai. I currently live in Silicon Valley, California, and I have been living here for 30 plus years, and I have been part of various ventures as well as various companies about it. So let me, I will go some background about me. So I am from Sri Lanka, from a small village called Puloli in Coimbatore, northern part of Sri Lanka, and I lived there until I was, I finished my A levels. So some of the message I'm going to give you is going to be, how to connect, because I was one of, most of you guys, came from this Sri Lankan system with O levels and A level, and going through, some of you went going through universities. So I was, I did the first part of it. I went to the elementary school and secondary school in Sri Lanka, and I studied at Hartley College. So before that, so I am, as I said, I'm from Puloli, Sri Lanka. Hello, Aparna.
Yeah, you can go ahead.
Okay. Okay. Yeah. So I'm from Puloli, and I was, my family was, farmers and business people locally there. I am the seventh kid of, 7 children family, and I lived in Puloli for all of my life before leaving Sri Lanka, and I went to Puttarema Vityalayam, then completed my high school or A levels at Hartley College. I give a lot of credit to my achievement and my accomplishment to what I learned through Sri Lankan education system and what I learned in Hartley College. So that is the first part of it. Then after I so as part of my family, And I got married to my high school sweetheart. She was from also Ploli, and she's a doctor from the University of Jaffna. Again, that's the thing. We are from basically Sri Lanka, and we have done all of this. And I now currently live, as I said, in San Francisco area. With I have 3 kids, and so that is my background. And to talk about my journey of it, so there was a civil war, as everybody know, in Sri Lanka. As I was part of Hartley College, it had some impact, and we lost the building for a while. I moved to another school, and we completed my A levels. After that, I left Sri Lanka. I didn't take my A levels due to the war. I went to Africa and completed London A level, and came to US, and then I went to a university called University of Minnesota, and where I did undergraduate bachelor's degree in electrical and electronic engineering. Then went to Stanford University, where I completed my graduate studies in again electronic engineering. So it's a mix of electronics is computer engineering. Some people talk about it. Some people say it's electrical engineering, and so it is a mix of electrical, electronic, and computer engineering. And I completed my degree in 1993 from 1994 from Stanford. That was a fertile time for a lot of these electronic business, if you look at it. And so I was in the right time, the right place, and I was able to go. After that, I went and started working at a company called Rockwell Semiconductor. They used to build computer modem chips, which goes. I don't know. Some of you may not know about computer modems. That's how we used to connect our computers to the network or to the internet. And so this comes within your PCs or home computers, and you connect that one. And so I went and worked for Rockwell. After that, during that time period, it was interesting enough. There was an opportunity for me to join the early stage startup company called Broadcom. You guys would have known about it. It's a multi-billion-dollar company now. So I was would have been an early employee, and I chose to stay with my job, which paid good money, but the other one had the stock option, and the upside was there, but I didn't realize that. So I chose not to go there. I stayed back. Fast forward about a year or year and a half, that company goes public. The people who used to work with me or work for me went and joined that company and became multi-millionaires. So that's the time I realized, wow, there is something beyond just working for a multinational startup in big companies, and you can go do different things and make a lot more money. And during that time, you can enjoy your life also. So that was the turning point. And just before getting married, I went and quit my job, corporate life, and with 4 other friends, we started a company called VXTEL, which I will be referring to that in the later part. This is a voice over IP company. This was when internet was started establishing, and network was getting built. And so we were, there was a lot of voice calls people were making, and people were trying to move that one to over in internet, fiber and internet interconnects. So that's the time I joined. So we joined, these 4 of us joined and started a company called VXTEL. That's where we did the voice over IP. We raised money, and we built a product. Within 2 years, we got few customers, and luckily Intel acquired us for about $600 million. Early stage of the company, and I stayed with Intel for the next 4 or 5 years. And after that, I left, and I was wondering what to do. There were a couple of the co-founders from my previous company. They were started thinking about the data center. We look at the data center again, this big electronic market. That one, So where they were starting to think about these data centers needed a lot of cooling, a lot of compute, a lot of performance. So we came up with some ideas to address that market. And there we started in developing some SSD, solid state devices, which is, again, it is prominent now, but 2006, about 15 years ago, it was not as, prominent in this industry. So we were again the trailblazers on that area. We went and built that, and it took a while, about 7 years, and we built the company. We sold a lot of product, and that company got acquired by Western Digital, where currently I work there. So first 20 years of my career, I was a hardcore engineer, managing teams, developing product, taking it to market. So that's a story I'm going to talk about today. But last about 5-6 years, I have moved into customer interaction, mainly like sales and managing people. Like big customers like Google, Facebook, Oracle, big customers who are building this infrastructure using this electronics. So I will be talking about some of the current trends and how things are going. Okay, before I go in, I know there are people from various backgrounds who will be watching this video or listening to live now. So if you look at electronics, that has transcended the whole world now. If you look at it, it's in everywhere. So for example, in the consumer electronic area, that's the picture I put it from the internet. I took the picture on the right side. If you look at it, all your cell phone, all your tablets, all your drones, all your pens, even all the skating boards, everything is now have some form of electronics. So in that electronics, you have controllers, displays, there are power electronics, sensors, memories. You can name so many, portion of the electronics. So if any one of you guys are coming from the electronics background or want to go into this industry, I mean, people talk about electronic or hardware design that has multiple smaller field within there. But I will be talking about it a little bit later. But these are the products come out of those fields. Then the other part of it, because we talked about the consumer, which is the you and me users do that. Then if you look at the cloud market now, you have heard about AWS, Azure, or Google Cloud, Oracle Cloud. There are so many of these cloud is being built out, and those users everywhere the electronics. So if you look from the top, the Google Cloud, it has data centers, it has racks of compute, storage and memories, and then it has application running on that. There will be a lot of people now, the computer science field is so famous. A lot of people are writing software code in that field. But, as an electronic person and a hardware person, we should be proud of it. All of those, codes they write, it runs on this, our platform. And without our, foundational technology with the frequency or with the power or with the features, it is very difficult for software people to exist, I would say. So in the electronic field, if you look at it, what are the components which comes into this? If you look at it, there are CPU from Intel, AMD, and there are many other companies doing that. Then memory chip like a DRAMs, which come from Samsung or Micron, and there are networking from Cisco and various networking companies, Broadcom, and then storage, which is I'm part of. Like there is Western Digital, Seagate, and then you look at it, there are so many other SSD companies like Toshiba. Then you can look at it, Samsung, Micron. And there are many other startups doing that also. And then, so these are the components. Then if you look at these components that we put together in a box, so that's in the chassis. So that's the mechanical engineering. But see, the one thing I always mention to people about is the best thing about our Sri Lankan education system was that we were able to learn about, math, science, physics, and chemistry during our A-level time. That is a foundational technology for all of these. So if you look at physics, you learn about mechanical, thermal, heat and light and various aspects of it. And if you look at the semiconductor business, semiconductor field, you see a lot of electronics items which are built by using all the chemical reaction as well as the chemistry or material science of it. So all of these foundation, which it was set up by my, I always say the A-level education I got in Sri Lanka, which and then I went deeper into my college life, able to help me when I go now design, because I manage a team which build these boxes with thermal, mechanical, designs, and I use all of those concepts. And then you have displays. That's another kind of technology. It's part of electronics, part of material science there. And then you have racks and racks of these servers sitting in the data center aisles. Those data centers aisles need to be cooled well, and it has to be power. It has to be distributed well. So there are so much intersection. Even though we say electronics, it is not just electronics. So the people who are doing a bachelor's degree or early stage of the career, just make sure. I know you need to go deep into some of these fields, but make sure you take this breadth of classes which you will teach, just more than just basic, basic electronics. And then if you pass that into the industry-wise, the industrial electronics. What does that means is, like, for example, car or somewhere very cold weather or somewhere in desert. So the consumer electronics are a little bit narrower area which has been developed. But in the industrial electronics can work on the wider area for from a heat point of view or from a thermal, as well as vibration, and there are different factors. So I'll talk about that a little bit later about it. When you want to design a product, when you want to go and build a company or build a end-to-end product, you had to understand all of these standards, the certification process, that also which we need to talk about. Another one is automotive. Now self-driving cars are becoming kind of prominent, and prior to that, if you look at it, it used to be so much mechanical and wiring and all that. Currently, every car has a computer built in, so it's an electronic. It controls all the sensors and various aspects of it. And then you look at the cell towers. That is where we are communicating in a different area, which has so much electronics on it. So if you look at the bottom part of it, if you look at it, so many different industries which we, as a electronics person, we touch at this point. And so we should be very proud of it, as well as we should use this opportunity to take this technology to the next level, while we achieve some great results. So I was actually, one of the pictures I wanted to show here is, we are talking in Zoom in a webinar today. So how does it work? If you look at it, it doesn't just connect through the wires and all that. So, so when I am in front of a computer with the mic, and which is going through, because it has all electronics around, surrounding me, then it goes through the network. It goes to a data center. Actually, interesting enough, most of these, Zoom information is stored in the data center, and it goes to the edge network. They get routed, efficiently to where it needs to go, and it goes through the existing the network, and then other side the same way it get changed into a edge network, and then it comes to your home or wherever your mobile or various aspect of it. All of these, again, these are a lot of software which is running on it, but the electronics behind it is amazing. That the performance we were able to achieve, and where we are with that technology is what is the foundational foundation for all of this. So from an electronic industry point of view, if you look at it, I wanted to give you variation in various aspect of it. If you look at it, the consumer market, and we talked about everything, where everything there nowadays from your home, you have toys, you have nothing is without electronics anymore. And then there's the enterprise market, which I talked about, the cloud and compute, and there are performing data and high performance computing. That has a lot of electronics. And then automotive market, as I talked about. Next one is I didn't talk about earlier. One is the aerospace industry. If you look at it, it start with the drones, then go into helicopters, then go into a small plane, then passenger planes, then you go into rocket ships, which goes into space, then it's spaceship. All of these have so much electronics in it. Actually, if you look at it, this aerospace and the defense and military were the foundational investors for to get the electronics business off the ground, because I'll talk a little bit later on that. And then you have AI, machine learning, and deep learning, which is very prominent now. The reason for this one is if you look at NVIDIA T4, the PCI card, or they have the new ones, also I think A100, various things. Again, there is a software portion of it, but without this hardware, it doesn't run this fast. It doesn't do this work which we need to do. So that is, again, electronic. And IoT and wearables. If you look at the IoT, I work with some SenseMate guys, and I talk to many other people, and there are so much industries are opening up with this IoT. Because IoT is, basically it used to be human. We have these sensors where we can, hear, smell and see and all that. That is being replicated in a smaller scale by the IoT devices. When we talk about IoT, it's not just the chip. There are sensors. It has, smell detectors and chemical, mechanical, all of them together. And then we, add that as wearable, for in the healthcare. Because look at it, I am wearing this, Apple Watch, which has so much, potential in that because of all the electronics we have packed into that. Then look at the telecommunication. That was my first startup in the voice over IP industry, and I talked about, and I'll be discussing more on that. But that is the end-to-end, fully electronics business there. And I talk about the defense and military and the healthcare and digital therapeutic. That is becoming so prominent now. A lot of technology, because early detection or continuous monitoring can help alleviate a lot of issues which can come later. So this is being so prominent. With the COVID, it is becoming even more important. And all the doctors see us through Zoom, as well as they do most of the detection and most of the checkups using the digital technology. The other one is we can't the farming is our blood from when I came from Sri Lanka, and now it is becoming very smart farming with agriculture and the food technology. There are many different research is been happening. All of these uses electronics. And I'm sure I left out some of them, but it is so important. So now I'm going to go a little bit down on the electronic side before, So the way I organize the presentation is, the people who are studying these, electronics, they need to understand why they are learning these foundational resistors, transistors, capacitors, and all the, op-amps and different different things. But later part, when again that you will study. But here in this presentation, which we are trying to tell you, what are the advantage of doing this one. So if I look at it, basic simple form of it is, I say there are three parts. One is the digital electronics, which is, on off, a Boolean equation. Then you start building from that one and zeros. You build, big machines and humongous performing things. So that is a digital electronics. Even though it sounds simple, but it has, a lot of electronics work behind it. The second one is the analog. It's a full analog, which is not one and zero. It has all the levels that is needed. Actually, when I talked about IoT and sensors and all that, this analog electronics is so important. And because it has to continuously monitor. There is no yes and no. There may be answers and all that. So you need analog electronics. Then there are mixed signal one, which you have some digital part, like like you would have heard about a thing called SerDes, and you would have IO pins, and they have both analog and digital mixed together part of it. So these are the main field, and there are a lot of subfields on this one. And the next level of this, when I think about building a company or building a product and building a solution, we can talk about we want to do these big things, but everything starts with the foundation. For me, the simplest foundation I always apply when I talk to a customer, or when we talk about a new product, is we start building from bottom up. What did we know in the foundation? Right? We have resistors, capacitors, transistors. There are a few variations of that one in the inductors and variable capacitors, diodes, and all that. But those are the foundation for every electronics. So I am sure the first electrical engineering, electrical or electronic class you would have taken is most probably logic design, and then microelectronics. In that you would have learned about all the laws, how do you put the circuit together. So that is important for everybody, because if once you know that, when there is a complex problem, you break down into smaller problems, and then you can go and go down to this level and make sure you're foundationally you are doing the right thing. But if you are somewhere stuck at the highest level and you don't know what the detail is, you will struggle. I have seen that many people doing that. They are very high-flying people, but the problem is when there is a real problem comes in, they don't understand. And then with these resistors, capacitors, transistors, and few other devices, you start building the integrated circuits. So those are the ICs, chips. You see it in that. It used to be millions of transistors. My first chip in my first startup was about 1 billion transistors, and now I'm sure it's multi-billion transistors, going to close to 1 trillion transistors in a chip. And then you have these chips, like you look at the picture right there, and then you have the PCBs where you plug this one in with interconnects to talk to each other. And so that's how, because see, you can't do, you can design as many chips as possible without interconnect. You can't do much, except for, now we have Bluetooth and Wi-Fi. Those technologies are prominent at this point, but still for that to work, you need to do work. And then you build systems with that. Systems are the boards, and then you have power supply, you have communication thing, and then fan for cooling and heating, and then put it together in a chassis, and that's how you build that. So these are the foundation to me. I mean, it's people can think so complicatedly what it needs to be do. When I do sell product to big customers like that, people ask me, how do you understand the application? The application would be so new or so different than what you are used to. I say I break down to these ones. So everything, you look at it in a system has to communicate, operate interoperable. So that is the interconnect you are looking at. Then you look at it, what are the features they are looking for, and look at it, can that be mapped into the storage or the processors we have? And how do you break that down? And then you move the data through that. There is a pipeline, the data coming through network, going into the local memory, and then going to the CPU and get stored in the the permanent memory, or it get pushed back, with some results. So that's how you look at it. And so if you break down into that, foundational part, as well as some of the building blocks, you will start understanding what electronics, mean in a design terms. So it's a short part of the history of electronic components. If you look at it, I think we used to have this, the TV came in 1950s, 1960s, and all that. The normal, the electronic TVs. The prior to that, you have this, the tubes and different technology. But the concept was, it was using that on-off kind of transistor switching, and then that get to make it micro level, people moved into this semiconductor business. So that's where the transformation happened. And I would say it was in 40s, 50s time frame where the World War II was ending, and then Korean War. That period of time, with a lot of investment in this area, people started looking at it. How do you get this military win by doing the technology rather than sending the people to fight the war for you? Or even when you're fighting, how do you communicate to say where the enemies are, where the targets are, and all that? So this was in 50s, 60s started, and then actually the first for the electronic people, a little bit deep, the CMOS technology is the most prominent now because it has a lot of advantage, a lot of scalability, and all that. But the first one was NMOS transistors. That's what PMOS and NMOS transistors, they used that one to design a lot of these computers. And then they went into the CMOS, which has magnitude of scale for performance, low power, as well as scalable from a manufacturing process point of view. And then after that, it just keep scaling. And one of the most prominent law is Moore's law. Moore was one of the founder of Intel, who said every year and a half to 2 years, the size of the chip will half, and the power will be half, and performance will be doubling on that. So those are the foundational for this electronic business. And if you look at the right side of it, if you look at again, continue to be a lot of investment from the governments and all that. Now, if you look at a warrior or the army or soldier, you will see fully from head to foot, they have technology everywhere. So that was the foundational part. So now you are started designing with billion transistors. How do you do that? I mean, how do you know all those are lined up right and connected right and works well? Because another reason is if you made a mistake on that, the process going to manufacturing and coming back, it used to take about hundreds of $1,000s. Now it's in millions of dollars. So you don't want to make mistake on all that. So the electronics, where most of the students would have learned about CAD tools, which does all these first design and then rule checking, and then you do the rule checking from a logical point of view, and then rule checking from the performance and is it operating right, and then you go into the manufacturing rule where when you go this one and manufacture in the chip level, or at the PCB level, the printed circuit board level, will this work? So you had to go all that. And, again, when I started my career at Rockwell, that's the time they were transitioning into working with CAD tools. Prior to that, they will design, small chips. It's about thousands of components, but they will have a desk where they will be drawing these by hand. And then they take this one to somewhere to micro, make it micro level, and then they go and print it out. And they said the failure rate was quite high. And I was one of the guys at Rockwell to bring in some of the tools to automate this one. And that was the early 90s, late 80s and early 90s. So this is another area of the field in electronics is as important, because without the support from the CAD, companies and CAD tools, you won't be able to go and design these complex products. So some of the example of these companies are Synopsys, Mentor Graphics, Cadence, and there are many other small companies there. And then, you design the component, you design the small part of it. So then you go into the, electronic design of the full system. So these are, as I said earlier, it comes into the box, and then you take that product, and then you had to put it in a data center. So in this area, you learn basic electronic components, but then the mechanical part becomes as important or more, the structural part of it and thermal side of it. So there are multiple disciplines come together to make things work in this. And if you are knowledgeable about this one, you get a lot of advantage working in this area. And that's what I was blessed. Again, I go back to my A-level studies on physics and chemistry and math, where I learned about heat. I learned about all the mechanical part of it. And the applied math, we learned about all the stress, the structure, structure part of it. So all of these come together in these data centers. So every data center has people from all these different backgrounds working there to make it go 24/7. So it is important for us to learn about that when we are doing that. So this is, mostly, I talk about, the electronic business and electronic market. So if you have any questions, please send to Abana. I will answer that afterwards. The next phase of it, I want to talk about the process of building a product in an electronic company and how I will map some of my experience to that. Okay. So I don't know if you guys have heard about product lifecycle. It's called PLC, which is very critical in any industry. And they use different process, waterfall or agile, and I'm sure there are different other names and all that. But it is important. The reason for it is being important for any companies or anybody to do that is this one gives method to the madness, because everybody, engineers have crazy ideas. We come up with so much, cool ideas. We come with sometimes wrong ideas. So by having an established process in place, when you make a mistake, again, everybody is going to make a mistake and all that, you can go and correct it. You don't repeat the mistake. So the product lifecycle normally gives that methodology. There are gates, there are check and balances, as well as most documented way of doing, the complicated things. So when you go through that process, and when there is success, you try to repeat that one and go and enable that one to everybody. Or when there are failures or there is some issues come and happen, you'll be able to go and fix that one by using that one. So I'm going to go through that a little bit here. So and that is the setup for it. But why is it even more important in the hardware business or the electronic business? Hardware is hard, and there are two angles here. One of them is hard, mean it's solid, and so it's not like a software you can hack bug fix and release it tomorrow. This one, it takes time and to do that. Okay. On the other side, hardware has many factors. It can influence the product. So having this process, very well set process, it gives you predictability of execution, as well as when you don't do that, you understand where those variables are, you can fix it. The second one is even more important, like high capital investment. If you look at a product development for software, people say, oh, 2 weeks I can put this feature out, and then 4 weeks we can release it to the customers. No, the hardware side, minimum I have seen is 6 months. And if you want to design a chip, it's about 12 to 18 months. So if it is a PCB hardware board, you can do it in 6 to 9 months. But if you have to do the chip, and then and the time and the money, as I said, to design a chip and go and do these tools and the manufacturing, it could take multiple $1 million. So you have to be careful with that. The other area is opportunity cost. So you say you go and make a mistake. After 18 months, you find a mistake, and then it may take another 6 to 9 months to fix it. So you lose that close to a year there. And this is one of the reasons, actually, I pride myself in making less mistakes and making sure there are enough backup plans to recover from these mistakes quickly. That's how I was, and I have been successful in both of my startups. And there are mass production requirement. If you look at it when you go to manufacturing, because you are not in most of the startups or the small companies are not going to have manufacturing facilities. So you need to work with a third party, even further land in Far East or some other countries. So for that, you need to understand what are their requirements are. So that is where this process, there are gates where you check it out and make sure all of them are passing. And then other side of it is regulations. When you design hardware product, again, as I said, you have a safety requirement, you have an EMC, electromagnetic certification needed, and there are many other related part of it. So you need to make sure you meet that. So you have gate for that. Then you have warranty, support, implication, because if you, as I said, forget about building a wrong product and finding out before going to market. So look at the other side. You go to market and you find a problem. And most of these products, mainly in the enterprise product, it will need to be returned, and you have to pay back the customer money, or you have to give them a new product. And whatever the old product, it's gone. And so you have to be very careful about that. So for that, in mind, there are many different form of a product life cycle. What's the question? I don't know. All right, I'll answer at the end maybe. So if you look at this, there are product life cycle. There are I have established this one in both of my companies. I was VP of programs for many companies. So that is where I come up with the simple 6 phases. So what the phases is, you start with an idea. So idea, you talk to people, and then you had to do a planning, and then you had to go and execute the product, and then you had to do qualification, certification, and check with the customers. And then if it's successful, you go into volume manufacturing, and then you have to support the product to the end of life. So this is the 6 phase of developing a product. So I'm going to go through each one of them a little bit more detail here. So the idea generation is very key. And if you want to do your own company, or if you want to build within your company a small area, and I encourage people who get into electronic business or even any business for that reason, start talking. Once you are there, learn from talking to product managers, talking to finance people, talking to manufacturing people, talking to your adjacent areas where you may be like software people. Okay, so this one gives you overall vision of what is the there are. So if you look at this diagram here, it talks about where you have a market weakness. For example, as I said, when we talk about the voice over IP market, that was expanding, but the product which was Texas Instrument was the one, our competition, the product was not ready, or it wasn't good enough. And so that is the weakness there. Internal strength, what kind of strength you have as a team, you can do this. And again, you don't want to go and build a rocket ship without an aerospace engineer or someone who has worked on that industry. Yeah. So it's similar to that here, you need to have a background. I'll talk about that later. And then adjacent possibility, that's an interesting, that's the reason I took most of these diagrams from internet. The adjacent possibility is so important. For example, as I said, we worked on at Rockwell Semiconductor on the modem chips, the DSP, the digital signal processor, which goes into modem to do all the and a management of communication and echo cancellation and various things. But we found, and so we understood the foundational technology was DSP. Then we took the DSP. That DSP was, one of the products we did follow on at Rockwell was a GSM chipset. The GSM is the before now 5G, 4G, and all that. GSM was the standard for wireless communication, and so we designed a chip which will go and help do that function efficiently. And so that is another DSP. And the third one, which we identified that time, that company was not doing, was the voice over IP. So that was the adjacent market, but with the same foundational technology there. And so that is, that's what you had to talk about it when you're looking at it. So you need to back some weakness where you can go with it, and then you have a strength from your team point of view. As I said, so I'm going to talk a little bit about the product which we built at VXTEL. That was my first startup, which got acquired by Intel. So we had a strong DSP background. So our CTO was, he was a PhD. Actually, he's from IIT Madras, and he did PhD in US. And then we had another PhD who was the firmware engineer. And the third one was me going as the hardware, software guy, which can do, take this idea and make it into a product. And as I said earlier, the internet was taking off. Internet protocol was, being built out by many of these countries as well as the telcos. So that was the, somebody else was doing the heavy lifting for you. And then there is an ITU standard. This is the International Telecommunication Union. They had a standard because when you send a signal on a voice over internet, it get compressed, it get encrypted and send it over that. When other side it receives it, they has to understand what it is getting, and it has to decrypt it, and uncompress it and send it as a voice call. Yeah. So before that, the standard was established. So everything was coming out at that time, right time. And as I said, then the weakness was the existing solution from Texas Instrument was not like, in one chip, they were able to do 4 calls, So what I mean by that is, go to the next page. So this is where my solution was sitting, my chips, because, you guys make, people make calls, it comes through the, come to the junction at your, some data center or close to your home, and it get accumulated and send it over, copper lines prior to that. And when we came, this voice over IP, because the internet protocol and internet fabric was getting built out, so this one started sending over internet protocol. So what we did was we designed this chip which will convert into IP, and it will compress the chip as well as do the echo cancellation. Because echo cancellation mean in the communication is when you send a signal, it bounces back and comes from the other end. So you need to make sure that whatever come back doesn't get added to the going signal. That way it will start echoing and making a lot of noise. So we designed the chips to do all of those functions in there. And as I said, our background, I had DSP and low power semiconductor. As I said, our CTO had a very high architecture and system level background, and we have other people with a software background, so we put them together. So then second phase of the implementation is planning. So you need to make sure you have firstly you understand what product you're trying to build, your technology is matching that, and then you have the funding to there. When you have the money needed, you need to do this called NPV calculation. So you're going to invest say $10 million to build this one, and you will send it to market in 2 years, and then you are going to be in the market for another 5 years. So the net present value calculation is, it calculates if you put $10 million if you borrow from somebody, and will you make that return for that money as well as some profit on top of that. So the accounting people will do that. but it's good to know about what that is. And then you have to do a detailed project plan, because the detailed project plan includes the headcount, timeline, what are the risks, and how you're going to mitigate, how you're going to do check and balance, all of those. And then in this phase, you do the check on what kind of technology is available in the market. Okay, for example, when I was doing this one, there's a called TSMC, which is a Taiwan semiconductor manufacturing company, as well as there are other companies in Japan they were doing. The TSMC made it so easy for us to onboard, so we chose to go with them. So the Japanese one was very heavy lifting. So I had only 15, 20 people in my team, so we had to make it happen. So if you look at that, in the P1 part of it, the picture on the right side is actually the product which the second company we built. And this is actually my hardware. My team designed this hardware. So this is a storage hardware with 2 to 4 terabyte of flash memory sitting as a SSD with a controller, which we designed it. So you need to make sure the market is right, and then you have the finance to be able to make this one, and then the technology. As I said, you have to choose the right hardware technology, right form factor, and right the team of people to build this one. So this is a lot of people said this is not doable, and we were able to do that. And then with all of this, now you have to go to investors and raise money. Or if you are in a part of a big company, still there are a lot of process in place there. You have to be able to go and convince the upper management or the finance team to be able to invest on this. Then if you go past the next phase is execution. This is where a lot of time spent, because other ones are planning. Here you are building the product. Now you had to go and make sure whatever the plan you are committed, you are tracking to that plan. If not, you had to make adjustment. Again, people tend to misunderstand this one. Everybody makes all the schedule get pushed out, or everybody makes some mistakes. But how, as a manager, as a leader, you continue to monitor that and avoid as many mistakes as possible. And when you have small mistakes, and how do you do have some backup plan to go and recover from that? So those are the one which you have to look at it at this phase to make sure you are continuously making forward progress. And this is what is different between a software only product versus the hardware or hardware software product, because here we can't do partial releases. You can have a minimum viable product, MVP, but it has to be a product. So that is very important for people to realize. In the electronics business, you don't take half steps. You take a full step. That could be a small full step, but if you have to be able to, the product has to demonstrate some functionality or some feature of that. And then you do the QA and testing, because that is very important in for silicon. As I said, the electronics manufacturing can take millions of dollars. It can lose 6 to 9 months. So you don't want to take the shortcut and try to fix it multiple times. Okay. And as I said, in this angle, you need to, if you want to do a startup, you have to have some unique differentiating IP. That's where people miss again, because if you think about, if the big companies can do that, sometimes they miss, but even if you go and make it, they'll come and wipe you out if there is nothing unique about your technology. So you need to make sure you can, some patternable ideas, and then some creative way of solving problem. What do I mean by creative way of solving problem is, if, for example, if you look at Intel, or as I said, take the Texas Instruments, our competition, the design team was 300 people, and my team was 30 people. So I am competing against them. It is not that I am, being smart or something. I optimize to what the problem I am trying to solve. So they were using the DSP, general purpose DSP, to solve this particular problem. So we targeted this one. Then within that, that's the reason I put this picture out here. I have about 30 plus, patents US patents in various electronics area. How those patents actually, if I go and explain to my sixth grade son, he will understand this is not super smart, but it is a very creative way, very specific, and very good way of solving the problem. And how I do come to that is I look for everything straight line. I mean, from here I have to go to another point, and how do I get there fastest? There may be sometime thick pipe. Like for example, if you're going at traffic one, you choose the lane where there are multiple lanes. That way, there's a traffic you can pass through, or you try to avoid traffic lights. So these are like if you look at the electronics, I looked at those as the wires and look at the flip flops or latches as the traffic lights, and the cars as the electronics. So if you look at that comparison, so you find the optimal path. It may not be the shortest distance, but it's the optimal path you do that. Then you find the team. Actually, that is another biggest part of it. For example, if you are a junior joining a team and you want to make sure you find a place where you can learn. As I said, when I went to first job, even though I was at Stanford, I was in Silicon Valley, I chose to go to Southern California to get my first job. The reason was all the people I talked to in that company were very, very those people were very intelligent, as well as they had a lot of experience. So I could learn from them about that. So one of the interesting story on that one is there was an architect. He was a head architect for all the product and all that. If you look at it, when again I want to go a little bit technical for electronics people. So if you are designing an adder, so when you are doing a 4-bit adder, you keep adding. Once it hit all ones, when you add one more, it will go to 0. Then it will turn over. But same adders and these concepts are used in a plane, the digital technology for plane. So if you're taking over a plane going up, and suddenly say you flip over, or saturate, it's called saturation, the number, suddenly the number will become 0. So plane will go up and drop down. Yeah. So you need to have some technology to think if it hits that level, you have to rearrange that number. It doesn't suddenly go to the negative number. So those are small foundational thing which I learned from these guys, and I experienced from these people. And then you had to execute, and that's where you have a clear trackers. The team works together as an interpersonal part of it, early indicators of issues, and these are very important and simple. Again, I do a lot of mentoring. I talk to different people. If somebody here who's doing companies, who's doing or having trouble getting over this, distressed companies, reach out to me. If I can mentor, I will help you out. Because a lot of these people miss these simple indicators, and then they find the problem after 6 months, and then you can't recover because you are already sunken cost all the money, and your time is gone, and all that. The next one is, again, it's important after execution. Now, it's a hardware product has a completely different way. So you need to go through certification, you need to go through all these, qualification. So I put some of them like a UL or CE or RoHS and manufacturing. It's a different part of it. You have to make sure it is successful. And in this one, when you have a product, one of them is testing, and you have to test in the customer side also. So we were lucky enough at the first company at VXL, Intel became our partner, but they were looking for a solution for voice over IP, and they acquired a company called Dialogic prior to us, and they needed a product, like ours to work on their environment. So we worked together, and that's how we build that relationship. Eventually, Intel acquired our company for it. The next one is the volume manufacturing. So once you do the small manufacturing, small scale, you have to do higher volume manufacturing. So this is a big one for a lot of people miss this one, and they think about, oh, I built five of these, it should work when you do 5,000. No, it won't. It's called Murphy's law. So anything can go wrong, will go wrong. So you have to make sure you put all the safeguard around it, continuously quality checking, and making sure the manufacturing flow, manufacturing process does not change. Okay? So you have to continue to do that. And again, this is where I think, one of my pride movement, I said one of them is Intel, and we were able to do that. The second product, I was part of that founding team, which, we designed this product. This is the SSD. We were replacing, all the hard drives at that time to give higher performance. So one of the biggest, our customer was LinkedIn. So if you were in LinkedIn from 2012 to 2018, 19, most of your queries would have gone through my product, because our product was the caching product, which was sitting between all of your the data and your access, because to respond very quickly, very fast, you had to have these SSDs in that, and we were the sole manufacturer for LinkedIn for a while that time. The last one of this product flow is every product has end of life. It will hit sometime. So you need to make sure you need to continue to monitor that. So during that time, two things. You have to tell customers this product, because the components are shortage, or it is, we are not going to manufacture anymore. It's not efficient. So we will have to inform that. The meantime, the product team start working on it. Actually, even prior to this one, the product team will start putting the roadmap for the next product. They will start working on it. Okay. So hopefully you guys get the feel of it. Again, it's not just electronics. It's not just this learning what you learn in the classroom. That is very foundational. That is important. But understanding the flow, understanding this one, and when you can contribute and ask questions, are we doing this right or wrong? And if the end of the day the company is successful, or if somebody notices that you have the breadth view, and you can go places. And that's my story has been. So from a key takeaway from this, I think we are pretty close to an hour now. So the main takeaway from that one is, the electronics is not electronics only. It involves multiple disciplines. So make sure you get in, when you are studying, get to know that. When you're working, talk to those people who are in the different areas. And it is capital intensive. So you have to be careful what you have spent. But on the other hand, once you are in, the people call it stickiness is very high. Because once you are designed in, the next 3-4 years, they don't want to redesign it on that. The product, the life cycle, design cycle is long. So you have to make sure you make the right choices, right decision, reduce the complexity, and build the right product. And the quality, as I said, because of the returns and the failure and bad reputation, the consumer electronic, if there is bad reviews, bad reviews, the product will go away. And the last one is, you have to understand what are the, the various levels of standards and certification you need to know. That way, you can plan it accordingly. But all of these are the kind of, I talk like a challenge. On the other hand, what is a positive thing? The market size for electronics is trillions of dollars everywhere. As I said, I will start with the same story again. If you look at it, it was, it used to be a living room and office, then now moved into kitchen, then moved into bathroom, then moved into bedroom. Everywhere there are electronics now monitoring you, talking to you, or taking care of you. So if you look at it, this business is going to continue to grow significantly. So I think you guys are who are in the electronic in the right area, but not just knowing electronics may not take you to the next level. understanding overall flow, understanding the adjacent fields will help. That's my last one. Aparna?
Yeah, Ruben. Thank you. So if you have any questions, audience, please raise your hand. We will unmute yourself so that you can ask the questions, or you can post it in the chat or in Q&A.
There was a question on how to do hardware. I don't know what that means from a in a simple form, but I would say you have to study for it somewhat. And after that, there are areas. I know in Sri Lanka there may be limited opportunities for hardware, so that is where I think you have to look at it and see, working with various, as I said, SenseMate is one of the companies. They do hardware, but they don't design the chip. Just like that, I think there are other companies who do in Sri Lanka. And I was even told there is another company called Synopsys, which is a big, prominent company in Silicon Valley. It has operations in Colombo, maybe University of Moratuwa or close by there. So there are places you can go and learn, but you have to be part of it. Okay, so somebody asked that question. Yeah, so I would say, as I said, there are areas, because I am listening, I'm talking to people, as I said, various area in agriculture. There is enough. And then there is another person, I forgot his name, but he's doing some solar technology in, just fundamental solar technology, buying these components and putting things together for lights. And then if you look at it, pollution and various, sensors, and there are enough areas there. And then, and I'm sure, all the other areas, all the big corporations would have some electronics opportunities, but designing from bottom up may be limited. My hope is, once you, and one of the effort I am doing is trying to connect people from Silicon Valley to work with that. So if you go into like AI, machine learning, big data, which goes between software and hardware, and that area can be, there are projects you can get and work on. Yeah, risky. It's interesting because I'm part of Western Digital, and they were one of the prominent of risk. The ecosystem they were building that. The person who was CTO of Western Digital was, and he retired now. Prior to this one, he was one of the part of it. It is interesting, and I mean, actually, I've been hearing that a lot of Chinese and companies are doing that, and maybe even Russian and different thing. And it's very prominent in US too, because the RISC-V architecture seems to be catching up. And again, RISC architecture has been coming in and go from a MIPS, and all of my my patents, maybe half of it about some of the RISC form, using the RISC idea. RISC is reduced instruction set computer, so that part of it, I was able to. So again, I'm saying there are so much, if you look at ARM, and then you have there are so many variation of ARM chips now. So everybody does some version of RISC. So the RISC-V is one version of it. So that's what I think. Yeah, so the quality assurance. So someone asked about, Ramesh, how are you? I know, so you are the one doing the solar panel part of it, I remember, I think. So what a key aspect need to look into. So the first one is the quality assurance is the reliability. So the reliability means is the reliability of the components. So you see, if you're doing at the PCB or the system level in the electronics, so you have to first put together a list of all the components you're going to be using and making sure those will meet the minimum requirement you are putting for the product. That's the simplest way of starting on that. Once you do that, then they're going to multiple, as I said, there are certification, there are requirements by governments or regions. And so you need to make sure it meets that. And the third one is the quality assurance part of the hardware. I think I didn't touch much on the RDT. So it's called reliability demonstration testing. So what that is say you're going to sell 1,000 of something. So you take, based on that, you take, say, 10 samples and you run through, there are tests, accelerated tests. So you go in the high temperature or high voltage, you run it quickly and you try to say you want warrant for 3 years. So you can run it in 1 month, like mimic that three part of it. So there are schemes for that. There are people study these in PhDs, how to do these accelerated tests in a smaller sample and shorter time. So that way you can go and warrant the product accordingly. So this is a big field of it, and I think when we talked about in a few years ago, this is the important area, because you will see you put something together, it works for a day or two, and then you give it to the customer, after a week it falls, they're going to give back everything. So you need to make sure you are, all the components you're buying meets the minimum requirement, and then you can transfer it. All big companies are moving to custom SoC. Can we do anything from that? Yes and no. I mean, as I said, my first company was custom ASIC, which we raised money and we built everything. Second one, we started that way. But with the 2008 financial problem, as well as with the customers who we were working with, they needed flexibility. So we went with FPGA, the field programmable gate arrays. So we worked and we put enough parallelism, enough smartness. This is where the cleverness come of the architects and all that, how the software and hardware can work together and do that. So that is how you get to market quickly, because if you had to do a SoC, it takes a long time. Okay, so you just have to make sure that whenever you are doing this the custom SoC, you have a customer. Again, I mean, I wouldn't discourage anybody, because I did it in my first company. I was 28 years old. I was young and stupid, and we went and raised $75 million. We were so bold to do that, and we got we were successful. But not everybody gets that because we were able to build the product in about 12 months. And so that's the important part. If you want to do custom SoC, simplify the problem, make sure software can do most of the heavy lifting, and then you have the value. Why do you do SoCs? Because it has lower power, higher performance, and you control your destiny. That's a good one. But on the other hand, if you miss on the functionality or the chip doesn't work, you are done. Yeah, possibly. Is that the area RISC comes to bridging? Again, I'm sure it could be, because I know about the technology-wise what they were trying to do, but the approach, I know a few of those main people, but I haven't been kept in touch with this chip business lately, because I moved into system, I moved into sales. I'm doing that at this point. Any other questions? So one of the, few of the interesting things also I can tell you also is it's interesting sometimes, you want to do. One of the things when I was at Stanford, me and one of my classmates, he's from Pakistan in 1993-94. So we went and designed, so we had to do a class project and we were thinking what we could do. And we went and designed a cricket game in hardware. We designed model date and all that, because that time US the baseball and those games, so it started coming on the video game like environment, and we didn't see anything available for cricket. Actually, we went and did the whole 32 state machine with, how everybody bowls, how things moves, how you swing the bat. So you use the engineering and math and physics background, and we designed it, and it came and worked first time. It was interesting enough. I had a choice of staying and continuing that. And my professor at Stanford was saying, hey, this is like an interesting market because cricket is a big market in the world, and you should continue with me, and let's see if we can make it productized. But I got a job offer with good salary, and I choose to go that path. But it was interesting to see now all those gaming technology, the sports technology has so much come around. So I feel good that I had done something in that area too. Let me read that Landrian's question. I just want to escalate one question. If the patent for a solution of problem had been ever, if there is any upgrade in the concept by another guy, who will be the pattern of future pattern? Both of no, I think it's depend. I mean, if you go and take the idea and then make significant change. It had to be a significant change. It has to be. It can't be just I added a fan to something and it is it's my pattern now. No, it won't work. But you had to have a significant. So this is the your patent lawyer will have to understand that, as well as then the U.S. Patent Office or whoever you're patenting it, they had to agree that one. This is where I'm very proud of myself because, as I said, in the first company, I have about 16 or 18 patents. Second one, another 16. So altogether about 30 to 35 patents. All of them got approved first time because we knew we were doing something unique, and it was not done before. But it was, we were not going, so hard. I mean, because if people make it so convoluted, it can't be implemented, it can't be justified. So we found the solutions very simple, but we were able to go and defend that one easily. So thank you very much. I like the presentation approach. It is impressive. I understand that you are pressing on the process. Yeah. So I am, so even though I consider myself to be a technologist, I understand technology. One thing I found out is people miss that in a startup. People tend to think, oh, we can do these things. It doesn't matter hardware or software engineering. One day we will do this. One day we'll do this one because I am the smartest guy in the room. I can do this one faster and go about it. That is the wrongest, the wrong approach to me. To me is, you need to have, every time you do something, you need to have somewhere written down a simple form, why you are doing, what you thought. 50% you may fail, you will succeed, 50% you will fail. So when you fail, to go back and say, what is the assumption you made? And you don't make that mistake again. So those are the what I mean by the process. So every startup I was part of, I did technology contribution and all that. After I hired the right amount of people, smart people to work for me, I just focus on the process, tracking, and people are not going crazy with ideas. Because guys, as I said, 300 people versus 30 people, you are 1/10 of the force you have. And if you waste time arguing about stupid things, you are going to be failing. Okay, so you need to find where you are going to succeed, and then you establish those simple processes, not a hard process, but simple process. You have to do that. You're told it may take a hardware nearly 12 to 18 months to come out of the manufacturing. It can survive in the market for certain time frame. After that, how does the investment and ROI are measured? Yeah, so this is an interesting thing. As I said, it's a 12 to 18 months. So you invest, say, $10 million that time. And as I said, if you had to have a big customers behind that one. And, if you put a $10 million and, as a ROI, as I said, 10 million has to be recovered. And normally the net present value calculation is they assume a 15% return on capital. Okay, so basically, if you take a loan, you get 6%, or in US is the low, and in Sri Lanka, I know it's the high interest rate. You get a percentage, and 6%. So the companies, if you look at it, they say if you look at the CFO, Chief Financial Officer, he wants to have a 15% return on that capital in the lifetime of the product. So the lifetime of the product could be 3 years after the 2 years, the first development time, or 5 years. Normally, 3 to 5 years from there. So that is where you had to do that calculation. Again, this is a financial calculation. There are smart people do those. Any other question, Abarna, or anybody came up?
I think all the questions are over. Thank you so much, Ruben, for this insightful and informative session. I'm sure our audience today and the viewers would have spotted some opportunity. And also, I would like to thank all the audience for joining this session. Thank you. Take care and stay.